Hello everyone, welcome back to my YouTube channel. Myself Mahendra J from Sri Venkateswara College of Engineering, bearing the USN 1V21EC049. I am from ECE branch, Saint Vincent and Mangalyaan. Today I am here explaining a presentation on IP traffic processing. Let us move on to the presentation insight. Moving on to my second slide comes introduction to IP traffic processing. IP traffic processing involves the handling, management, and optimization of data packets transmitted over IP networks. It is essential for ensuring efficient communication between devices on a network. Understanding the fundamentals of IP traffic processing is crucial for network performance and reliability. Moving on to the next slide. Basics of IP networking. Here we can find some basics which are very important in IP networking. IP stands for Internet Protocol, which is a primary protocol used for sending data across networks. Devices communicate using IP addresses that uniquely identify them on the network. There are two main versions of IP network. The first version would be Internet Protocol version 4 and the second version would be Internet Protocol version 6. With IP version 6 designed to address the limitations of Internet Protocol version 4. Moving on to the next slide, which is the third slide, we can get to know about role of routers in IP traffic processing. Routers are devices that forward data packets between networks based on the destination IP address. As the name suggests, the basic work of routers is to forward the data packets by showing it the path which it is supposed to move on by tracking the destination IP addresses. They play a crucial role in determining the optimal path for data transmission. Routing algorithms help manage traffic loads and ensure data reaches destination efficiently. We know that at some point of time there would be huge traffic loads with multiple packets incoming and outgoing. At that time, routing algorithms help manage these traffic loads. They make sure to ensure the data reaching its destination and in an efficient manner with that aspect be noted. Moving on to the next slide. Traffic analysis and monitoring. Monitoring IP traffic involves analyzing data flows to detect patterns and anomalies. Network administrators use various tools to capture and visualize traffic for better decision making. Effective traffic analysis helps in identifying the bottlenecks and optimizing network performance. We know that the network administrator use various tools to capture and visualizing these things make a better decision making process happen. It also involves analyzing of data flows to detect patterns and anomalies, and it also helps in identifying the bottlenecks and optimizing even the mobile networks. Moving on to the next slide. Quality of services, in short to be known as QoS. QoS refers to the techniques used to manage network resources and ensure reliable service delivery. It allows prioritization of specific types of traffic, such as voice or video, over less critical data. Implementing QoS helps maintain user experience even during peak traffic times. Moving on to my next slide. Security considerations in IP traffic processing. IP traffic is susceptible to various security threats, including DDoS attacks and packet sniffing. Implementing security measures such as firewalls and encryption is critical for protecting the data integrity of that particular IP. Regular security audits security audits and monitoring can help identify these vulnerabilities in the network. IP traffic is susceptible to various security threats, including DDoS attacks. Audits and monitoring can help identifying vulnerabilities in the same network. Moving on to my next slide. Network address translation. NAT is a technique that allows multiple devices on a local network to share a single public IP address. It enhances security by hiding internal IP addresses from external networks. NAT also helps in conversing the limited pool of Internet Protocol version 4 addresses available. Moving on to my next slide. Traffic shaping and bandwidth management. Traffic shaping involves controlling the flow of data to ensure optimal use of bandwidth. It can help prevent network congestion and enhance the performance of real-time applications. Techniques such as rate limiting and queuing can be used to implement effective bandwidth management. Moving on to my next slide. Emerging technologies in IP traffic processing. Technologies like software defined networking SDN and network function virtualization and FWAN are realization in traffic processing. These innovations allow for more flexible and efficient management of network resources. As networks become more complex, embracing these technologies is essential for future proofing IP traffic processing. Moving on to my next slide, which is the last slide. Conclusion and future. IP traffic processing is a vital aspect of modern networking that requires continuous adaptation to new challenges. The future of IP traffic processing will likely involve greater automation and intelligence through AI and machine learning. Staying informed about trends and advancements in this field is essential to professionals in network management. Thanking you. This completes my presentation. Thank you, one and all.